Hello, everyone. Welcome to this conversation. I'm Dr. Mili Thakur. I'm a reproductive endocrinologist and a fertility specialist. I'm also a medical geneticist and founder of Genome Ally. November is National Family Health History Month. So at Genome Ally, we have dedicated this month to raising awareness about the importance of family history and how that can help pave a way for a healthy living. So today I have an incredible guest here with us. Her name is Dr. Susan Liebman. She is a renowned expert in molecular genetics. She's a distinguished university professor emerita at the University of Illinois at Chicago, and she's a research professor in the Department of Pharmacology, University of Nevada, Reno. She has over 35 years of teaching experience. She's authored 100 plus influential research papers and has secured $13 million in research funding. She's a big advocate for genetic testing. And the reason why I connected with her is I was captivated by her upcoming book, The Dressmaker's Mirror. So without further ado, I would just have Dr. Liebman share some thoughts about her journey through discovery of her family history and how it led to this incredible book.
Thank you so much. Thinking back into when I decided to write this book will drag you all back a few years to the early months of the pandemic. And we didn't know what to do with ourselves. And we discovered this thing called Zoom. And I had been a member of a book club. And I said, okay, let's meet on Zoom. We can't meet, so I became the head of this book club all of a sudden, and nobody wanted to read a heavy, serious book. We were all, remember, blue and afraid. So I picked out this book called I remembered reading a series that was very, very light, Mrs. Polyfax. Millie, do you know the story of Mrs. Polyfax?
I know, yeah.
All right, well, I got to tell you about Mrs. Polyfax. In the first book, we learn that she is a 65-year-old widow. Mm-hmm. And she goes to her doctor with various complaints. And he says, your problem is you don't have something you like to do. Find something you like to do. Well, she did gardening. She met with her various groups, but none of that was inspiring enough. She said, I always wanted to be an FBI spy. He says, well, that's not quite what I had in mind. Well, she had learned karate and various things, and she went off to do that. And then the rest of the series of the books is this little old lady with her flowers hat going all over the world during the Cold War and being a great CIA spy.
Wonderful.
Well, when we have a book club, we have to ask each other questions about the book. This was a very fluffy book. There was nothing to really ask about. So I came up with the question. And to me, by the way, when I first read this series, I was in my 40s. This was a really old lady. She was 65 years old. I mean, how could she do this? It was so exciting. Now, running this book club, I was past 70. 65 didn't look so old to me anymore. But anyway, this youngster at 65 was going around the world. So I asked people what it is that you have never gotten to do, that you've always wanted to do, but now most of the other people in this club were my age. What haven't you gotten to do? And in order to ask that, I had to ask myself, what hadn't I ever done? Well, by then I had enjoyed my career for about 40 years in genetics, in teaching and research. I published articles. I had a hobby when my kids left me an empty nest. I went back to my hobby of art, and I did lots of painting and drawing. I was a wife, a mother, a grandmother. And in the recent decade, I had become very interested and passionate about genetic testing. I had started giving talks about genetic testing, teaching in medical school, and going through social media to kind of promote genetic testing. And it occurred to me that another way to promote genetic testing that I had never done was to write a book and tell my family story. So that's a long version of how it is I came to write write the book. So what happened in my family to make me a proponent of genetic testing? Why was this important to me? It all began 15 years ago plus one day. So yesterday was the 15th anniversary of the day in which my newly married 36-year-old niece went out with her husband to the same day that he was going to turn 37 and go out to dinner later. But she was pregnant. She had to eat every 10 minutes. And so they went out, they stopped off for a snack in downtown Brooklyn in a Columbia restaurant that they enjoyed. And this is a picture of Karen and her husband on that very day. She's 6 months pregnant. She's thrilled. You know, she was 36. She wasn't sure she'd get pregnant right away, but there they are, newly married, and they've got this baby coming, everything they always wanted. And while they're at the restaurant, just about to leave, they gave her a card saying, you know, rate us 1 to 10. She said, oh, I'm going to give them a 10. And she slumped down in her chair with her eyes open. And her husband said, Karen, are you fooling around? But he already knew. He could tell she was dead. They called an ambulance. It was there within 2 or 3 minutes. They tried to, you know, restart her heart. They took her to the hospital. But shortly thereafter, they came out and announced that she had died. They did an emergency cesarean section, tried to save the baby, but he was too young. He lived a minute or two with some drug. I think her husband was able to hold him, and he died.
I'm sorry.
So, you know, Karen had some symptoms, and she'd actually asked her doctor. She said, you know, I've got this cough I can't get rid of. Doctor says, well, you know, you're a 3rd grade teacher. You're catching all this germs from your students. And when I climb the stairs, I never used to get out of breath. Now I'm all out of breath when I go up 1 flight of stairs. Doctor says, look, Karen, you're 6 months pregnant. Everybody who's 6 months pregnant gets exhausted when they go upstairs. Well, it turns out that wasn't the cause. The cause, what caused her death, and we'll get to that in a minute. So they did an autopsy. The New York City coroner's office, of course, because, you know, what was this? Poison? I mean, we were terrified. And they didn't find anything in the autopsy. So the pathologist decided to send Karen's heart out for further examination, and she did that. She also took a fair amount of Karen's tissue and saved it in a way that would actually allow for further testing. And that was very forward-looking of this particular pathologist. And I'll tell you about her. Well, I'll tell you right now. It turns out that she became, in years later, when I contacted her, she had become the first female chief of the New York City coroner's office, medical examiner's office, Barbara Sampson. So it took a week or so for the results to come out from the examination of Karen's heart. And what they told us was that she had dilated cardiomyopathy. And this was a terrible shock for the family. Why was it a shock? Because my sister, Karen's mother, had been diagnosed years earlier with dilated cardiomyopathy. But they told us that it was caused by a virus. So my sister, when she first got sick, she was also a 3rd grade teacher. And she was also coughing and coughing. At first they said it was a cold, and also you're catching it from your students. Eventually they said it was bronchitis. Then they upgraded it to pneumonia. And by this time, you know, I live far away from my sister, but I talked to her on the phone every week, and she was sick, and she was sick, and she was sick. So I called her son, my nephew, Jeffrey, whose wife was a doctor, and they lived in Boston. I said, you know, something's weird here. Diana's sick all the time. He said, oh, you know, I've heard that. We're going to go visit her. So they got on a plane a week later, and they went to visit. And my niece-in-law, who was a physician, took one look at Diane walking across the room and getting exhausted, and said, you know, Mom, I think it's your heart.
Oh.
Go to a cardiologist. And within that week, she was diagnosed with dilated cardiomyopathy. But she didn't take drugs. She didn't have diabetes. She didn't have any of the causes. And looking at family history, nobody else had dilated cardiomyopathy. So what they told her was, a virus caused this. It's caused by a virus. Well, and by the way, dilated cardiomyopathy hits about 1 in 250 people in the United States.
And is it mostly viral? Like it's mostly viral?
No, it's mostly genetic. More than, upwards of 50% of the causes are genetic, but they didn't know that then. This was 15 years ago. It was early days. So whenever they couldn't figure out the cause, they said, oh, it must be viral.
Yeah.
But it turns out that it's generally not viral. It's generally genetic. So of the 1 in 250 people who have dilated cardiomyopathy, most of them don't know it until they die.
Yeah,
So,
that's what happened to Karen.
And that's what happened to Karen. So with my sister, she had warning. And and some of the time that happens, but other times, the first you hear of it is when you die. So finding out ahead of time to get treatment before that event would be extremely valuable.
Yeah. So you found a link when the coroner's office brought that information and said it's dilated cardiomyopathy. And then was it the first time that you saw that there was some connection that this could be genetic?
Absolutely. So I said, oh my God, Karen has dilated cardiomyopathy. Her mother has dilated cardiomyopathy. I don't think it was a virus. I think it was a mutation. It was a gene.
Sure.
And so I panicked because I had children, and Diane had a son and grandchildren. We were both very, very worried about this, and we set out to find that gene, find the mutation, so we could warn the rest of the family. And one thing I didn't know, whether it was a gene in the family. Could it have been one of our parents had it? And my mother had nephrosis and was very ill much of her life. My father was very healthy, but he died of a heart attack at 66. So it didn't seem like it was in the family. So one possibility was that it was new to Diane. So each of us gets about 5 mutations new to us that our parents didn't have. Usually they don't cause any trouble, but occasionally they do. So, I didn't know, was I at risk or maybe not? So we set out to find the mutation, 15 years ago. This doesn't seem like a very long time ago, but in the field of genetics, that's back to the dark ages. They knew there were a few genes that could cause dilated cardiomyopathy, and they suspected there were. Researchers got the idea that there were a bunch more, but they didn't know what they were. So Diane went to Miami, where Dr. Ray Hirschberger was a genetic cardiologist working on cardiomyopathy, and he sent out her blood DNA to check if she had any of the, I think, 5 mutations, genes they knew of, and took a long time. And finally we get the result, and nope, didn't have any of those mutations.
Yeah, and nowadays it's so easy to send a big panel and do all that. So back then,
so I'm a yeast geneticist, and I talked about my family when I would go to the Chicago Yeast Genetics Club. And I discovered that one of my colleagues' wife was a genetic cardiologist, Elizabeth McNally. So I became her patient, and she also looked after my sister. She corresponded with her doctors. And every year or so, she would send my sister's DNA out again because new genes were discovered. This went on for quite some years. And finally, Dr. McNally told me, well, first of all, she told us, we know it's genetic. We don't know the mutation. You have to assume you have it. Get an echocardiogram every year.
Oh, wow.
And your children should get an echocardiogram every year. And your nephew should get a echocardiogram every year. So if we find something, we can treat you before you die. So we were doing that. At least I told my children to do that. Actually, my husband was not too happy about this.
Yeah.
He was afraid that we'd frighten them, that they were young, that they wouldn't want to have children of their own. So we made a deal. The deal was I could tell them once, this is what the doctor tells you, you should do this. But I couldn't ask them every weekend or every month or even every year, did you do it?
Yeah.
That was up to them. They were adults. And so that was the deal my husband and I made. So I told them, I didn't know if they were doing it. I hoped they were doing it.
Yeah. So Dr. McNally then was your like segue into finding the condition. Like at that time, Diane's testing had come back negative with the panel, right?
That's right. But Dr. McNally sent her DNA out again to the updated panel, and then the next updated panel, because things changed, but it still was negative, nothing. So she said to me, you know, I have 5 patients like your sister, everything's negative, but we suspect that it's genetic. You know, a few years ago in 2003, she says, genetic testing cost $1 billion. To do the first sequence of the human genome was $1 billion. But by the time she decided to do it in 2003, no, that was in 2010. Yeah. So Karen died in 2008. By 2010, the price had fallen to a mere $50,000.
Yeah.
And nowadays it's, you know, a couple of hundred. So it's just amazing. But Dr. McNally had some grants to try to find new mutations in new genes. And she said, I'm going to sequence all the genes in all 5 patients and see if I can find anything. So that's what she did. And in any of those cases, it's pretty difficult. There's 20,000 genes in our genome. And, you know, so she just looked at the ones she thought might affect the heart.
Yeah.
And she found something that looked like a smoking gun to her. There was a mutation that destroyed one of the genes, and it was in something that was a component of muscle, also a component of the heart muscle.
Yeah. What's the gene called?
The gene was FLNC.
Okay.
It's a filament in the heart muscle.
Sure.
But she wasn't sure if she was right, so she didn't tell me. She published a paper, but she didn't tell me because she, you know, didn't have real evidence. Meanwhile, my family moved away from Reno to we moved away from Chicago area to Reno to be near our grandchildren. And she moved from the University of Chicago to Northwestern University to head up their genetic cardiology group there. So I wrote to her office, to her genetic counselor, after I moved. And then I stopped hearing from her, never heard again. So when my sister died a few years later, when she was 73, so, you know, medicines were able to keep my sister alive, and not only alive, she had a normal life. Yeah. She could only play doubles tennis, not singles tennis. That was her restriction. But she, you know, she had a wonderful life with the medical, with just the pills to get rid of. It never changed her heart function, but it changed the way she could live with that reduction in heart action. So when my sister died, instead of writing to the genetic counselor, I wrote to Dr. McNally.
Sure.
And said, you know, what's up? You had all of our stuff. You told me you were excited about something. I never heard back. And she wrote me back immediately. She said, you know, I moved to Northwestern, and the emails that you sent to the genetic counselor never got forwarded, but my email got forwarded. And so she told me about, by then, a couple of years later, there was a little more evidence for this FLNC mutation being the cause. And so she told me about it. And of course, I went on Google and I found yet another paper that she didn't know about with the exact same mutation, not just that gene. Turned out the author was the son of a yeast geneticist I knew. It's a small community. But this particular person had said, don't contact me. So we didn't know anything about him except that he had the same heart dilated cardiomyopathy and the same reduced heart function level that my sister had, and he had the exact same mutation.
So how in all of this did you become that medical investigator, going back all those family tree stuff? Like, how did that information just like spark that in you?
Well, once I knew the mutation,
Yeah.
I thought that I had to tell the family.
Okay.
And indeed, it's, I think, standard practice. Dr. McNally's office wrote a Dear Family letter.
Okay.
Explaining all of this to the family, but it was up to me to find the people to send it to.
Sure. Then did you go back generations to look at?
Well, the first thing I did was to try to tell my nephew.
Sure.
And he was very interested in it and very concerned. He had 3 boys. So I wrote him a text, we've got it, write to me. He says, oh, hooray, I'll be right on it. And then a few hours later, I get a text. I can't follow this up. My wife, the doctor who diagnosed my sister, was it not diagnosed, but figured out that she had a heart problem, is too upset. She doesn't want to know. It's too frightening. And oh my God, if I had it, the 3 boys might have it. She says, we're already doing echocardiogram for you every year. When the children are old enough, we'll do it for them. That's all we can do anyway. Mm-hmm. I don't want to know. It's too frightening. Well, this is pretty upsetting to me. I had an unspoken deal with my sister that I would protect them. And now they don't even want to get tested. But I had to respect their decision. I mean, that was what they decided. So I kept prowling the literature. And a few years later, there was another paper that came out and described many families that had mutations in the FLNC gene. Sure. They were called truncating mutations. So there was, 20-something families. And the upshot was an echocardiogram could be normal and you could still drop dead.
Oh.
You needed to have an MRI, and you needed to have a Holter monitor to find out if you had arrhythmias. And so I got back to my nephew. I said, this echocardiogram isn't the whole answer. You have to do these other things. And so they reconsidered. And my niece, Jeffrey's wife, said, well, I don't want to frighten the kids with all of this. Okay, go ahead, get the test. Mm-hmm. So that was going to happen. And by the way, if you have the mutation, first of all, they would still just do these tests for you every year, the same as you would have to do if you didn't know if you had the mutation, just if you were at risk for having the mutation. So if you didn't have it, you didn't have to continue. If you had it, you had to continue this. And if they found something, they would treat it. They would treat it with the same pills they treated Diane for dilated cardiomyopathy. If severe enough, they could implant a defibrillator to restart your heart if you die, if your heart stopped beating. And in bad enough cases, they could do a heart transplant and give you a whole new heart, lease on life.
Did they have it?
I was going to keep that a secret, but no, they did not. So it was a wonderful news for them.
Yeah.
And by the way, I wanted to tell you that when I told my children, so I got tested, of course, and I also won the lottery. I did not have it. Okay. So I told my children, you don't have to get tested anymore. So when I told my daughter, oh my God, I'm so relieved. I was so worried about my children. And I was, every time I coughed, every time my heart fluttered, I was sure I was dying. And, it's wonderful to know this.
So the genetic testing actually helped your children to feel reassured, because your testing
helped my daughter to feel reassured.
Yeah.
So when I told my son, he said, testing? Was I supposed to be getting tested? Oh, yeah, you told me about that. Oh, yeah, I went to my doctor and he told me he asked me, does your mother have dilated cardiomyopathy? And I said, no. And he said, well, if your mother doesn't have it, you can't have it. Doctors are not informed about genetics because just because I didn't have the disease, dilated cardiomyopathy, didn't mean I didn't have the mutation. I might get dilated cardiomyopathy next year. It might not show up for a while, or it may never show up. But Michael, my son, could have inherited the mutation and he could have died already because they weren't testing him. So by knowing you have the mutation, I think it gets the doctor's attention a little bit more in this case. So that was
by having a negative test in a parent. So if a parent tests and they're negative and it's a condition that is passed on in, say, an autosomal dominant fashion, then their children would not have it. Like
that's right. Then they're done.
And they're done. They don't have to do testing, and then they don't have to keep doing in your, say, in this specific condition, the echocardiogram or MRI and all that.
Nothing. They're all done. But even if they don't have the disease, the parent, they could have the mutation, making the child have a 50% chance of having that mutation. And, according to my deal with my husband, I didn't remind him. He forgot about it, and he never did it because his doctor was misinformed and thought that everybody with the mutation would show it.
And I want to circle back to your book again. So this is 2020. You are in that book club and you're like deciding and what you should be doing. And in the last 15 years, your family has gone through all of this. So how did you embark on that journey of like writing it? And where does the Dressmaker's mirror come in there? Why is it titled that way?
I started by writing short stories about the family, and then ended up putting it together. And so I tried to find various people to tell them about the mutation in the family. And as I was writing the book, toward the end, I kind of tried to examine family history. Where did this come from? As I said, I couldn't tell if it was my mother or my father, but I knew my father's mother died suddenly also. She was 59 years old. She went to a birthday party for my father, who was 36, and, a little family party. And she says, I have a headache. I'm going to go home. I'll see you guys tomorrow. She goes home and she died in her sleep. The coroner said, heart attack. No autopsy. Same thing when my father died 28 years before Karen died on the same day. Actually, they asked us to do autopsy. Because he was with me in Chicago. My parents were visiting when he died. And so they suggested an autopsy. And my mother says, oh, it's against the Jewish religion. We don't want to do an autopsy. I didn't think it twice. The doctor said, okay, I'll write it off. You don't have to do it. And that may have found dilated cardiomyopathy, possibly, and it might have saved Karen's life. So, autopsies are a good thing. So I'm writing this book, and I can't understand where this came from. And I'm telling the story of the family. And one of the stories is about my father's brother. He had a brother who died when he was 4. And I knew how he died. It was well known in the family. This was a terrible tragedy. His mother, the mother, was a dressmaker, and she had a huge dressmaker's mirror. And she worked from home, and people would come in and she would alter their dresses or make new dresses for them. And my father's brother was there in the room, and he was crawling around, and he knocked into it, and it fell down on him, this very heavy mirror, and he died. He was killed. It killed him instantly. So my father told me this story. My uncle told me this story. I worried about it. I discussed it with my cousins. It was this tragedy. We didn't understand. She continued to be a dressmaker, which bothered me. You'd think that So I decided to look at the death certificate. Actually, first I had looked at it because we had this strange thing of, was my father babysitting when he died? Well, it turns out the death certificates told me my father was 2 when his older brother of 4 died. Oh. So then I took the death certificate. So obviously he wasn't babysitting. Took the death certificate. And I just wanted to see, what were the injuries? How did he die? And oh my God, the death certificate said that he was in the hospital for 5 days with congestive heart failure.
Oh, yeah.
No accident, no injuries. It was a total fabrication. Why would my grandparents put this terrible burden on my grandmother? Well, first of all, they lived in a town in Pennsylvania, Carbondale, and they had friends. My grandfather had a job he loved, and they up and moved. They moved to Scranton, Pennsylvania. And that's where and there were newspaper articles about this death in Carbondale. In Scranton, nobody knew. They came up with this story, and that was evermore the reason. The only thing I can imagine is, before DNA, they already knew about genetics. They knew about heredity. They knew probably there were some other deaths like this, and they didn't want anybody to know because they wouldn't want to marry their other boys.
Yeah.
So they kept it a secret. And, again, if we had known that, we might have, when my sister had dilated cardiomyopathy, we would immediately have figured out it was genetic. And it could have saved Karen's life. They were trying to protect their descendants, but it didn't turn out that way.
And if you go back to like the time where your father was a small child, like how old was his mother when she passed away? Like what is the average age of like people getting affected with this cardiac event?
4 is very young. It's very unusual. But by the age of 40, 90% of the males, if you examine them, if a cardiologist examines them, they wouldn't know about it, would show something. So it's actually what they call highly penetrant. Although not everybody dies, and many would live their whole life and never even know that they had this problem. But 90% of people by age 40 will show something if they get these tests by a cardiologist. There are other mutations in other genes that are less penetrant, where, and some that are more penetrant. Huntington's, there's nothing you can do about it, but everybody who has that mutation is going to get it. My grandmother was 59 when she died.
59. So yeah. Like I know in your book you mentioned at some point that your father celebrated his 50th birthday, and he mentioned that he's lived a full life, which if you look at in the general population, people would say that's like very young.
Right. So he got in big trouble when he was a student teacher. His father died when his father was 43, and my father was 16 years old, and that was still very much in his mind. And so he felt when he was a student teacher, and someone in the school died of a heart attack at age 50. And everybody was, oh my God, a tragedy. And my father, who was very well liked, very sensitive, very kind, said, well, at least he lived a full life. He lived till 50. And they said, oh my God, what an insensitive brute you are. How could you say that?
That was normal for him because in his family, 50 is like something that he's seen a lot of death by that time.
Well, he at least had seen, yes, he had a 4-year-old brother who died. His father died. His mother was still alive then, but he was still in mourning for his father, who died at 40, in his 40s. And he was thinking, oh my God, I wish he had lived to be 50. And so that was his perspective. So it weighed on him his whole life that he was such a brute. So when he turned 50 at the Passover Seder, he announced to the family, now I'm 50 and I can say it. I'm ready to go. My bags are packed. That's what he said. And he repeated that various times. I'd like to live longer. I want to see my children and grandchildren. You know, I was graduating from college at this point. My sister was just married, I believe, or just about to, maybe she hadn't found her husband quite yet. I'd like to be here to see all that, but my kids are launched. I've had a great career. I've had a wonderful marriage. I'm ready to go. But he lived another 16 years and he got to see a lot more.
Yeah. So are you thinking that based on the family tree and how you studied the whole gene, did it pass from your grandmother on your dad's side to your father and then to your sister?
So that's what I believe. So let me backtrack a little. When this paper that showed all of the many families that had this mutation and how an echocardiogram wasn't sufficient, I looked specifically at the mutations they all had. And there were 2 families that had the exact same mutation as each other and as my family, exact same as my family. So I wrote to these authors, asking them various questions, and the author wrote back, one of the authors, who there were many people that tested people all over the world. This was an Israeli doctor who wrote back to me and said, you know, my 2 patients who had your exact mutation, they're Ashkenazi Jews. Are you an Ashkenazi Jew? And I said, yeah. And so then I went and I looked up the inflammatory bowel disease exome gene display. And they had sequenced thousands of people's entire genome and just wrote down whether they had bowel disease or not and what ethnicity they were. Mm-hmm. And there were 1 out of 800 of the Ashkenazi Jews they sequenced had this specific mutation.
Yeah.
No other ethnicities had this mutation.
Yeah.
So first of all, I realized it wasn't new to my sister. It had been around a long time. And it was likely what we call a founder mutation. Yeah. So many times, unfortunately, in the history of the Ashkenazi Jews, there's been a Holocaust and they have been wiped out and a much smaller group was left. So about 500 years ago, there were a few thousand living in Europe and they stayed together. They intermarried. And one of those had this mutation, apparently, and therefore it's been passed on. There are other such mutations, BRCA, that are similar, that were in that group and that remained in that group.
And could you speak a little bit about like the conversation that families should have to talk about this? I think you talked a little bit about how different people in your family responded differently. Like when a person is talking to their family or even looking at their family history, first of all, who are the important people that they should be looking at to say, okay, tell me more? And then how should we approach that? Like,
in my family, it didn't work very well. And looking and thinking, I still had no idea if it was my father's side or my mother's. I really didn't know because she was so sick her whole life. And many people died young. When you go back, they died of cancer. They died of different things young. It's not easy to tell. And then there's people who hide, who lie, like in my grandparents, how we thought we knew, but we didn't. You can ask again, you can ask, but with dilated cardiomyopathy, people might not even know. They would never know. So my recommendation, if you really want to get at history, is get the death certificates. You can ask, but people about their health, you can, and it's not always easy to do that. If it's ancestors, if it's more than 25, 50 years, anybody can, in most states, get a death certificate. But otherwise, you have to be close family. And in some states, you can get it right away.
Yeah.
So it was no problem. My uncle had died 100 years ago. I was able to get the death certificate online in 10 minutes. But in some cases, that may not be easy. But I have become a proponent of widespread genetic testing because family history, first of all, is hard to get. And second of all, not everybody who has a genetic disease, it will show up in family history.
Yeah.
Many times it doesn't show up at all. So this is just a new area. It's not been accepted widely. I think that you do some screening on through your Genome Ally work, right?
Yeah. So for Genome Ally, we are a big proponent of like family history, at least some of the red flags. So having multiple family members with like unexplained death is one. Then another big red flag would be if there are young people with like cancers, if there's
Yes.
like 2 or 3 people with like breast or ovarian cancer, or there are rare type of cancers in the family, like, pancreatic cancer, or many men in the family with prostate cancer, all of those are red flags for a cancer inherited condition. If there
Right.
are like sudden deaths or stillbirths in the family, I think that is a big one. And then in our field of like pregnancy losses, like if there's 2 or more pregnancy losses, like we are starting to get a red flag and look at other things. Also,
Yeah.
a history of like early onset, either blindness or hearing loss, or if there is like unexplained infertility, like if the couple can't get pregnant, those are red flags. I think it's very important, at least for a young person, to keep their eyes and ears open and like ask pointed question of why this happened, or why, I think it's like, had in your family one or the other person been like aggressive about it and said, why did this happen, right? It's like, I think it's very important to not I think most families who have inherited risk, because it's happened so many times in the family and there's multiple things happening in the life, it's normalized pretty much. It's like, oh, it's just something that we have, or they don't pay attention. But as an outsider, as a person, when I'm putting a family history together, like if somebody was to say a young person just like Karen passed away, that would be a huge red flag, right?
Right. So in my family, there was no way the grandparents were going to tell you that the son died of anything other than an accident. They set out to lie.
Yeah.
After Karen died, my father was already dead. I spoke with my uncle and I said, who else in the family had unexplained deaths? And he said, oh, this is a fluke. Karen's death is a total fluke. It's never going to happen again. It's never happened before. I said, but Uncle Si, did it ever happen before? And he says, well, there was one case, but that was crazy. That was a fluke. It's a fluke. It's a fluke. He wouldn't tell me anymore.
Yeah. Yeah.
So when I went into the family history, I did find the case he was talking about. There was a cousin, my father's cousin, who went, not scuba diving, the other.
Snorkeling.
Snorkeling, thank you. He went snorkeling in the Bahamas on vacation, and he died.
Yeah.
And he was 32 years old. He had a child of 2 and a child of 4.
Yeah.
And eventually I contacted the widow and the son. The widow talked to me, and I wasn't convinced she was going to tell her son. Usually I tried to talk to the parent first, but I found I was able to contact the son, and he was really not interested. He wanted to know what I wanted out of this and why I was bothering him. And he wasn't, I'm not sure if the sister was still alive because I could never find her and he wouldn't give me any information.
But as you spoke
the
earlier,
autopsy on the father was a heart problem.
Yeah.
But yeah, so even when I pushed my uncle, I wasn't getting an answer. And that's why, well, nowadays we know more than up to 50% of cardiomyopathies are genetic.
Yeah.
One case of cardiomyopathy is enough to consider it's genetic. You got cardiomyopathy, you consider it genetic, you get a genetic test to try to protect your family.
And can you speak a little bit about like how simple these tests have gotten now? When I'm ordering these tests, most of them are like swabs from the buccal cheek. Like, can you speak a little bit about how effective and how easy they are to do?
They send you a test, a little tube, and you spit in it, and you send it back to them. So, a blood test that you get every year, that's much more complicated. You have to go to the doctor, they have to take the blood, then they examine it, and it sometimes actually costs more than the genetic test. And we never worry about a blood test. It might tell us that we have high cholesterol. We're going to have to change our diet. We're going to have to take a pill. Okay. It's not terrifying. We learn it, we do it. The same thing with a genetic test. It's going to give you an insight, a window into your family health. Usually, almost never is it a genetic, even in my terrible case, it's not a death sentence. It doesn't say you're definitely going to even get anything.
Yeah.
But there's things you can do to make sure you don't.
Yeah.
Just like changing your diet and not eating too much fat. In our case, it's getting your heart checked.
Yeah. And it's not like there used to be this paradigm of the genetic tests are always so expensive. Like now with all the technology advancement, can you speak for like how the cost has come down and it continues to be?
Yeah, so it's incredible. A panel of hundreds of heart disease genes can be had now for self-pay without insurance of $250.
Yeah.
Whether this will stay exactly, there's, the field changes a lot, and that's something that frustrates me. There are other organizations, some of the ones that do blood tests that doctors are very familiar with, which cost $5,000 still to do this test. So it's very helpful to have an organization like Genome Ally, that can help direct doctors to the $250 test instead of the $5,000 test, which is exactly the same.
Yeah. And I
hopefully
think
this will be regulated.
And that's, I think, one of the key things that we have to get the message across is that one, knowing that there is something to be looked at. And if there is a simple test, you do the genetic test and find something, it's not a death sentence. You could do medicines and you can do like preventive surgery and you can live a full life without getting affected by the disease. Like I've talked to so many people, who have initially felt nervous about the testing, but once they did it, whether it was positive or negative, they felt empowered because now it was right in front of them. They can tackle it. Like you can't tackle something when it's like a dark room, right? You can tackle something when it's right there. And most of the time, that testing is reassuring to multiple other people in the family. Like how you said, if a parent's test is negative, the children now don't have to live in the fear of that whole.
So all of that's true if you know the mutation in the family.
Yeah.
But if you have, for example, cardiomyopathy and you get a genetic test and it's not any of the genes that we know of, you're not done yet.
Yeah.
It's not one test and you're done, because we only know probably half of the genes that cause cardiomyopathy. And every year there are new genes. So if you don't get an answer, you need to test again and follow it over the years. And this is one of the problems with panels. It's so when we found out that the FLNC mutation caused cardiomyopathy, I looked at the panels that were available and none of them had FLNC. And I wrote to the genetic testing companies. I said, add FLNC, here's all the papers. And they said, oh, well, when we get to it 2-3 years later, it's expensive. And they, so panels don't get changed very quickly. But there's this thing called whole exome sequencing, or where they sequence every single gene.
Yeah.
And then the day you find a new gene, you can look at it. You've already got the sequence.
Yeah.
This is my dream, and I think it will happen. The price for whole sequencing is coming down too. Some of them offer it on sale for $200. Generally, it's $500. It can be a few thousand still. It seems to be clinical grade sequencing. They do it 31 times, but the analysis is terrible.
Yeah, and I
think they don't tell you what they're doing. They don't tell you what they've looked at. I did this with one of my husband's cousins who had a different a neurological disease, and Hal, the computer, came back and said, nope, you don't have any mutations. Okay, did you look at all of the mutations we know of? Can you tell me what you, oh no, Hal doesn't tell us that. What?
Yeah, and I think that's why whole exome sequencing, when we do it in genetics, like it's in a very specific situation, because it's like trying to find a needle in a haystack, or even like just the tip of the needle in the haystack, because it's like, unless you knew what conditions you're looking for.
I really don't understand that. So you have a panel of genes for cardiomyopathy. It's 200. You do genome exome sequencing, and you look at those 200 and you say, this year, for these 200, you're clean. Let's look at it again next year. Next year, there's 4 more genes added. You just look at those 4 more. Yeah. I don't know why we're not doing this.
Yeah, and I think the challenge that I've seen, one is the variants of unknown significance have to be curated every so often. Somebody has to be on it. And like for most commercial labs, genetics labs, they're putting out the report. They do curation at the back. Hopefully they should be doing it. But once the report is with the patient and the physician in that moment of time get frozen. They think, oh,
they're done.
They're done, because they're not gonna, they don't understand. And our health system, with all of its integrations that are in different areas, don't integrate all the time to the same chart. Patients move now. I see it all the time when we are putting records together at Genome Ally for patients. It's like, sometimes I have to like get records from Florida and other place and this and that, right, together. So I think an important message that I got is, one, genetic testing is easy. It should be done under the provider's guidance. Like, we have to know what we are looking for, and the right test has to be added. And then it's not very expensive. It helps. Not all family members are going to be on the same page in their response. But can you speak about the controversy? I think you just touched on it, about the screening in the general population, like offering to everybody.
So I would like to see general screening, because often there is no family history. And when they do general screening, 1 in 6 people have a mutation in what we call an actionable gene. So let me come back to actionable gene. I wanted to tell your listeners about a variant of unknown significance and explain to them what that is. When you get your genetic report, everybody's gene is a little different. And often there's no problem. It's fine. We're all just a little different. And they would say it's a benign change. There's nothing to worry about. You're just a little different from the one we have listed as our reference gene, but your gene could have been listed instead as the reference gene. So you're fine. It's benign. Sometimes they say, oh, this is pathogenic. We have a whole history of a lot of families that have that exact mutation, and they're all sick. We know it. It's bad. And then sometimes they don't know. It's a new mutation, and I have never seen it before. Nobody's been sick. Often it doesn't make a big change in the gene, and they call it a variant of unknown significance. That is often turned into benign, but not always. And so it's not a reason to frighten doctors to not order a test.
Yeah.
Let's just say, forget about variants of unknown significance. At least let's get the pathogenic ones. But you could look into it and try to get an expert geneticist to help you figure this out. You could wait a few years and see what happens, or you could focus on the pathogenic. Because doctors, not just students, this week I spoke even in a medical school class. They don't understand. I couldn't believe they were talking about cardiomyopathy and all of the causes, and genetic cause, which is 50%, never came up. Never came up.
Yeah.
The other professors teaching it didn't know. When you ask students about genetic testing, they still think it's thousands of dollars and you shouldn't do it unless you really have a long family history. Cardiomyopathy, you do it right away. So there's a lot of education that goes into it. Now I've gone away from what you had asked me.
Yeah, no, but I want to go back to the variant of uncertain significance. And that's basically, we have had cases, like I've had cases where I upgraded the variant. As medical team, the patient, and the genetic testing company upgraded the variant of uncertain significance to pathogenic based on a certain family. So like there was this family that I took care of. They came to us with like a condition with like their hair, nails, and skin are abnormal. There are 5 boys in the family. The dad is affected, and 2 of the 5 boys are affected, 3 are not. And we tested one of the male patients, and he had a variant of uncertain significance. It was in the right gene. It was in one of the genes that affects the development of hair, nail, and skin, but there was no precedent to it. And then because the family was available, we had all the infrastructure, we did the variant segregation and saw, do the unaffected people in the family have it? Do the affected have it? And then it's segregated in an affected population. So based on that one family.
Right, you were able to change it.
We were able to help the genetic company change it to upgrade to a pathogenic, and now it's a known mutation that will be pathogenic for any future families. So I think that's a big important reminder for physicians and genetic counselors who help patients. Is like, if there is a variant of uncertain significance, you keep that in mind. In a few years, go back and keep looking. And there might be answers there. The question we were like just addressing was the screening of people for like the whole exome on a population scale. I know it's very controversial and it's not recommended on a clinical basis right now, but like, what is your take on that?
Well, first of all, the American College of Medical Genomics has been examining this as one of the groups. And what they have done is they say, there's 20,000 genes that we all have. We think about 7,000 of them, when mutated, can cause a disease. A lot, we don't know most of those. We know quite a few. A lot of them, there's nothing you can do, like Huntington's disease. You probably know it because it's in your family history, but there are, well, you have a 50% chance. You don't know if you have it. But there's nothing you can do if you have it. Well, you could decide not to marry or have children, which some people have done. But they've picked out, every year they upgrade their list. They've picked out 81 genes that they call actionable. Because if you find a mutation in that gene, there's something you can really do to help your life. And we were able to get the FLNC gene included in that list. And there's 80 others. Largely, they affect cardiovascular or cancer, but there's other mutations as well. But they say a very strange thing. They say, if you happen to be sequencing someone's genome for some other reason, and you come across this mutation as a secondary finding, if it's one of these 81 genes, you should tell them. You should tell them. But they don't say you should test them. Test everybody for these 81 genes. I don't understand the difference. So best I can understand, ClinGen also, they have 400 genes they consider actionable, but they don't recommend general testing. And the best I can understand in pushing them is, we don't have the money to do this. People don't have the genetic counselors that are necessary to explain it to the whole population, what it means. And there's no point doing the test if you're not going to follow up. What's the point of finding out you have the FLNC gene if you're not going to get the echocardiograms and the Holter monitor? And we don't have the doctors and the infrastructure to follow up. So instead of changing all, and they're worried also that in some cases, the mutation may be pathogenic in a certain ethnic background, but not be pathogenic in the background of a different ethnic background, which has different background genes. So you worry people unnecessarily. So those are some of the arguments. I would like to fix those things, have more genetic counselors, have more and go ahead and do this testing. But you can still do the general screen testing. You can still get tested for the 81 genes. It's just that they're not providing it for everybody.
Yeah, and I think the important thing to keep in mind for our audience is it's important to discuss these things. I think the more the general population and the public is aware of these questions. Like right now, if we are struggling with even the doctors and, sometimes the family is even not interested. Like if we were talking, and that's why I think your book brings up that important point, like each one of those stories that is shared awakens like another person to look at their family history and seek genetic testing. So do you want to share the cover of your book? Like I can.
No, you reminded me of two things that I wanted to talk about.
Sure.
One is that I did a small genetic study. This was before sequencing was so cheap, when it was still pretty expensive. And when I learned it was an Ashkenazi mutation, I tried to find Ashkenazis who had dilated cardiomyopathy. And I just did little PCR, a cheap way to sequence just that specific allele.
Mm-hmm.
Well, it turned out it was very hard to find people who had dilated cardiomyopathy who were still alive. So after looking and looking, I found 7 people.
Yeah.
And 3 of them had this specific mutation. One of them, doctor told her it was a virus.
Mm-hmm.
And I still go on social media and try to talk with people. And I ask, how many of you have been diagnosed with dilated cardiomyopathy being viral? And I get lots and lots of answers. How many of you have been asked to have genetic testing? Nobody. And years later, they still have nobody. So that's one story. Oh, so I told her, just because I found this in a lab, that doesn't count. You have to get it clinical tested, done in a clinical lab. So she goes to her doctor and he says, what? Oh, I'm not going to do that. I don't know how to do that. So there's still lots of doctors who are frightened of this. Yeah. She had a heart transplant. She actually died and was revived and had a heart transplant. So she saw doctors at a different, for her heart transplant, and they went ahead and did the test for her, and she had it. So you really have to be your own advocate.
Yeah, and I think
look for different doctors who will do this for you.
Yeah, we believe that firmly at Genome Ally. Like that's why we created that ease of access to discuss these kind of things and like take the testing to an easier place, because it feels like genetics is a heavy word most of the time. It's like as soon as, it feels like most people are under the impression that, it's expensive, it couldn't be them, and then nobody listens to the family history. So we are here to listen, and like I think that's the most important thing that your book brings up, that awareness, so yeah. I can pull up the cover. I want to show it to our audience here.
So this is a cover I put together. When I get a publisher, they will, I'm sure, change the cover, but the title is now The Dressmaker's Mirror. My agent, I do have an agent, suggested the subtitle of Sudden Death, Genetics, and a Jewish Family's Secret.
Wonderful.
And this is actually a picture of my grandmother and grandfather and their firstborn son, Eugene, who died at the age of 4. So both the mother and the son probably had this mutation. By the way, I did get the DNA from my niece through the New York City coroner's office, and she did have the mutation because they had saved the DNA. And they've started a program called molecular autopsy, and they're advertising it to teach coroners how to save tissue that can still be used for genetic testing. And they've gone back to the people who died in New York City and with sudden death, and now they have genetic counselors calling the families from people who died 20 years ago. They still have the DNA. So there's a lot to be done about autopsies and coroners to help us. I'm sorry.
Yeah. Yeah. No, I think that's great. And then how can the community support your book? And I wanted you to share a little bit about your contact information.
Yes. Yeah, so I'm looking for a publisher. If anybody has any suggestions or is a publisher and is interested, please contact me. Here's my email, sliebman, Lieb as in boy, MAN, @unr.edu. And if you put in the subject of the email, interest in Dressmaker's Mirror, that'll help me notice it. If you write to me, you could I will write back to you when the book is, I'll put you on a list and write back to you when the book is published. So if you're interested in hearing about it, please write to me. And also, I'm considering sending out maybe yearly by twice a year updates on genetic testing. So if you'd like to be on a list to get an update about genetic testing, also please write to me.
Wonderful.
This has become the genetics and cardiomyopathy has become more known, and there's an organization that was just launched last month called the Genetic Cardiomyopathy Awareness Consortium. It's a group of many different cardiomyopathy groups with dilated and other types of cardiomyopathy, and with the foundations that support it, and with the drug companies. So you could check that out. It's a great website, geneticcardiomyopathy.org. And although my book is not published, I did, maybe 2 years ago, publish a short story version of the book. And it's a long link, so if you don't have it, it's probably hard for you. But if you look me up on the Jewish Literary Journal, Liebman, it'll pop up. I was in their 100th issue, the Jewish Literary Journal, and that's the published short story. So that's the links. Thank you so much for having me and giving me this opportunity and getting to know you and getting to talk with you.
Yeah, thank you so much. I appreciate you, Dr. Liebman, and best wishes for the book. We are going to be waiting to read the book and then spread the word. Karen's story is incredible, and how you put your life's work into that is also amazing. And I think the message to our listeners is that they should pay attention, and they should be looking for answers, and that helps us live full lives.
Okay.
Thank you.
Thank you so much. Bye-bye.
Bye.